Hello students. In previous few lectures we have discussed nucleophilic substitution reaction, how it takes place. Although we will be discussing a different type of nucleophilic substitution reaction in upcoming lectures. And the second lecture was about leaving groups. So basically what we are doing is we are studying every element as in not literally elements, but every segment of nucleophilic substitution reaction. So first segment was what is nucleophilic substitution reaction actually, and the second segment was one important part of nucleophilic substitution reaction, which is leaving group, and the third segment is solvent, because solvent is also important in nucleophilic substitution reaction. How it is important, that we will be discussing in coming lectures, but first we will classify different solvents, because before knowing the role of a solvent we must know how many type of solvents are there in the nature. So basically if we classify solvents, first of all, what is a solvent? That is the first basic question. What is a solvent? So solvent is any medium which facilitates ground for the completion of a reaction, or for any chemical reaction, any compound which facilitates ground. So always, if you remember in junior classes, you have studied solutes, solvents and solution, and you have always given this common definition that solvent is one which is higher in concentration. So it basically means कि solvent ऐसा होगा कि ग्राउंड है, तो वो ग्राउंड प्रोवाइड कर रहा है किसके लिए भाई? जो सबस्ट्रेट है अपना RX, जो अभी तक हम देखते आ रहे हैं RX, विच इज अल्काइल हैलाइड, और न्यूक्लियोफाइल, उन दोनों के बीच में जो अटैक होने वाला, उन दोनों के बीच में जो रिएक्शन होने वाली है, solvent will provide ground for that reaction. Solvent will provide different action, or different, you can say, facilities to remove leaving group from the substrate, or to solvate the leaving group, or solvate the substrate, or solvate the nucleophile. So there are different roles of solvent in a nucleophilic substitution reaction. So if we classify the solvent, it can be classified in two basic categories based on their polarity. First one is a polar solvent. Polar solvent. And second one is a non-polar solvent. As name suggests, polar and non-polar. So it must have something to do with polarity or non-polarity. Let's come to the point. What is polarity? So any molecule which has some dipole moment or net dipole moment in some particular direction will be a polar molecule. Any molecule which doesn't have, or which has net zero dipole moment, is a non-polar molecule. Now how do we calculate net dipole moment? That is basically based on vector concept or electronegativity. So there are two concepts involved in dipole moment, and I'll not dive into that because we already know what is dipole moment and how do we calculate that. Although I will be giving some examples of polar and non-polar molecules, you can relate with that and come to a conclusion कि how this is a non-polar and how this is a polar molecule. So first common example of a polar molecule, the most common solvent in nucleophilic substitution or in our universe, is water. That is the most common solvent. So water comes in the category of polar solvent. How it is polar? If you draw actual structure of water, you know that this bond angle is approximately 104 degree, and there are two lone pairs also. So net dipole moment of water exists in this direction. I will not go into detail why it exists in this direction. For that you can refer to different videos and different lectures, or you can refer to our previous lectures. So net dipole moment will exist, and a non-polar solvent is let's say CCl4, carbon attached with 4 different chlorine atoms. Now do not confuse this diagram as if it is in 2D. It is not in 2 dimensions. It is a 3-dimensional diagram. This is basically a tetrahedral molecule. So tetrahedral molecule is symmetrical, and if all the atoms attached to this molecule are same, then there will be equal pull force outwards on a tetrahedral angle. So that angle will be 109 degree approximately. So there will be 4 vectors acting at same angle, and they will cancel out each other. So net dipole moment will be 0. So net dipole moment of this compound, which is also represented by mu vector, is 0, and net dipole moment of this compound is not equals to 0, and that is the reason why this is a polar molecule and this is a non-polar molecule. And if these two molecules are being used as a solvent, we will call this a polar solvent and this a non-polar solvent. Now, furthermore, if we discuss, there are two types of polar solvents. First category is polar protic solvent, and second category is polar aprotic solvent. So all we have to focus on is protic, the term protic, and the term aprotic. Protic comes from a word which is very common to us, that is proton, right? So any compound which is first of all polar in nature and it has a proton to be donated to any other compound or any other molecule. So proton has to be there, and it is not necessarily true that every compound can donate a proton. What is a proton basically? Proton is nothing but H plus ion, right? Don't confuse proton with any other thing. In chemistry, proton means hydrogen. If you remove one, because hydrogen has one electron and one proton. So if you remove one electron from the hydrogen atom, it will be left with one proton only. So means proton is nothing but H plus ion. So any compound which is polar first of all and capable of donating H plus ion will be a polar protic compound. Now all the compounds having hydrogen are not capable of donating hydrogen. So we have to focus on the point that it should not just have hydrogen atom, it should be having hydrogen atom which can be donated to other compound in forms of H plus ions. That is also important. That we will discuss later on. So polar protic means compound having proton to be donated to the other compounds, and polar aprotic means it is polar compound but it cannot donate any hydrogen or H plus ion to any other compound. Some common examples like water, you know that water can donate H plus ion and it will get converted into H plus and OH minus. So water has the ability to donate H plus ions, and just now we have discussed that water is a polar solvent. So this water will come into category, if we specify more, water will come into category of polar protic solvent. Similarly, ammonia. Similarly, acetic acid. So these are all polar compounds, but they can also donate H plus ions, so they will be polar protic. So what is polar aprotic? So polar aprotic, this is one common example. You say acetone. What is this compound? It is acetone. Acetone has polarity in this direction, in the direction of oxygen atom. So it doesn't have dipole moment 0, which means it is a polar compound. Now, can acetone donate H plus ions? No. Why? Because this hydrogen is not attached with any highly electronegative element. It is attached with carbon. So I have used the term highly electronegative element. So which is one important term. Only compounds which are polar and they have hydrogen atom attached with either oxygen, which is one higher electronegative element, or fluorine, which is the highest electronegative element of periodic table, or chlorine, bromine, iodine, or nitrogen. So these are some common elements with which if hydrogen atom is attached, that hydrogen is acidic in nature, which means that hydrogen can leave this compound in form of H plus. So the compound will be called polar protic solvent. Now, I'll put some solvents over here and I'll ask you guys to think about it whether they are polar or non-polar. If they are polar, then whether they are polar protic or aprotic. I'll put some common solvents, okay? And then we will study the role of solvent in a nucleophilic substitution reaction in coming lectures. But I think up till now you are clear with the category, how we will identify polar and especially polar protic and polar aprotic. So let's talk about some common solvents which are which we will be using in organic chemistry. Like let's say water. I'll write polar. If it is protic, we will mark on protic. If it is aprotic, we will mark on aprotic one. Okay? And if it is non-polar, we'll just cross this column. So let's say water, is it polar? Yes, of course, it is polar. So to understand whether the given compound is polar or not, we will have to draw its actual structure and then see the movement of electrons in different direction, so that we will come to a conclusion whether dipole moment, net dipole moment is zero or not. That is not what we are discussing here, but I'll just give you an idea. So net dipole moment is not zero, so this is polar. Of course, it is polar. Now it is protic or aprotic. So this hydrogen can be donated in the form of H plus ion. So this is protic. If it is protic, it cannot be aprotic, because both are two opposite things. So protic cannot be aprotic. Again, if I write, just I have given some examples. Let's say H2SO4 is being used as a solvent. Whether it is polar or not, yes, it will be polar, very less polar, but it will be polar. Polar protic or aprotic. If you have confusion, you just draw the structure and you will come to conclusion whether compound is polar or not. It might seem as the same to you that the dipole moment will be cancelled out, but this is a double bond and these are two single bonds, so it is not equal. It will be less polar. You can say that it will be less polar, but it will be polar, and it is protic also. Similarly, acetic acid, ammonia, and there are different other examples which are polar and protic. I will list some different solvents also, which are very common and they have some common name, or they have some common abbreviations that I will be using. Like first one is DMSO. DMSO stands for dimethyl sulfoxide. Dimethyl sulfoxide. So what is dimethyl sulfoxide? This is sulfoxide and you attach two methyl groups with it. Methyl means CH3. Now, whether it is polar or not, for that you will have to see net movement of electron. So net dipole moment will be in this direction. So this is a polar compound. Now can it donate lone pair of can it donate hydrogen H plus ions to any other compound? No, because it does not have any hydrogen atom attached with one electronegative element. So it is not a protic solvent. So it will come into category of polar aprotic solvent. Next, if I attach CF3, this again it has same. These two are similar compounds. So polar, of course, yes. Protic, no. Aprotic, yes. Next is this compound is called DMF, dimethyl formamide. Okay, dimethyl formamide. Instead of sulfoxide, it will be dimethyl formamide. Or is it polar? Yes, of course it is polar, because nitrogen will pull electron density in this direction and then in this direction. So it will have net dipole moment, so it is a polar. Will it be protic? No, because hydrogen atom is only attached with carbon, which is not highly electronegative element. So it will not be protic. It will be aprotic. Next one is DM. So I'll just mention some common solvents so that you will not have any confusion when they appear in front of you. And when they write short name, then also you shouldn't have any confusion. DMA is dimethyl acetamide. This is formamide. F stands for formamide. This is acetic part. You know that already. So dimethyl formamide. Is it polar? Yes. Protic? No. Aprotic? Definitely. So these are some common polar aprotic solvents. Similarly, we can have some non-polar solvents also. We can use those examples also. Like benzene is a non-polar solvent. You know why benzene is a non-polar solvent? Because the net dipole moment in benzene is 0. Similarly, CCl4, carbon tetrachloride, is also a non-polar solvent, and there can be different methyl. Although methane cannot be used as a solvent because it is mostly in gaseous state, but if it is being used, it will be non-polar. So there can be different non-polar solvents. You can comment on them based on their net dipole moment. There can be polar solvents. They have two categories: protic and aprotic. Polar protic is one which is polar and it can also donate H plus ions to any other compound or ion, and aprotic is one which is polar in nature and cannot donate H plus ions to any other compound. So that is for today. That is all we will be discussing about solvents. In next lectures, we will discuss uses of solvent by detailed analysis of substitution reactions. Thank you very much.